You know, we always hear about Bitcoin as global money, right? But what if we thought bigger, like way bigger, interplanetary bigger? Today, we're going to dive into this really cool research paper that tackles a massive question. How could you actually make Bitcoin work between Earth and, say, a future colony on Mars? So let's start with something super simple. How do you buy a coffee on Mars? I mean, it sounds like a throwaway question, doesn't it? But it actually gets right to the core of the whole problem. See, any real economy, anywhere, needs to handle these small, everyday transactions. But the moment you try to stretch a system like Bitcoin across the solar system, well, you slam face first into a huge cosmic wall. And here it is, the problem in a nutshell. Right here on Earth, if you use the Lightning Network, that layer for super fast, cheap payments, it's pretty much instant. A few seconds, done. But getting a signal to Mars, well, you're stuck with the speed of light. And that means just the one-way trip for your payment data takes anywhere from 3 to 22 minutes. It all depends on where Earth and Mars are. So you have this huge clash, instant payments versus this massive, unavoidable cosmic delay. Okay, so that massive delay, that brings us to our first really big hurdle, the problem of consensus. We're not just talking about sending one payment for one coffee. The real challenge is getting the entire network, on both planets, to agree on the same version of the truth. And the villain in our story isn't some evil corporation. It's just a basic law of physics, the speed of light. See, the way Bitcoin works is that miners all around the world are in a race to solve a puzzle and add the next block of transactions. This happens about every 10 minutes. But just imagine, a miner on Mars solves a block. Awesome, right? Well, it could take up to 22 minutes just for the news to reach Earth. By that time, Earth-based miners would have already found 2 more blocks. The Martian miners just wouldn't stand a chance. It's an impossible race. And that's the thing. This isn't some software bug you can just fix with an update. No, this is a hard-coded rule of the universe. It's baked right into the laws of physics. That is the light speed problem. 44 minutes. Just let that sink in for a second. At their furthest, that's the round-trip time for a signal to get from Earth to Mars and then back again. A delay that big just completely torpedoes the idea of having one single synchronized mining network for both planets. It's not practical. You can't have a fair race with that kind of head start. Okay, so the obvious first thought is, hey, why not just slow Bitcoin down? Like, way down. If blocks took, I don't know, a few hours to mine instead of 10 minutes, that light speed delay wouldn't be such a big deal, right? But the problem is that would absolutely cripple Bitcoin for everyone back on Earth. The whole system would grind to a halt just to make things work for Mars. So yeah, that's a non-starter. So if messing with Bitcoin's core rules is a no-go, what's the answer? Well, this is where the paper gets really clever. The researchers suggest a much more elegant solution. Don't change Bitcoin. Build on top of it. And that leads us to the absolute #1 golden rule of this whole design. You do not touch Bitcoin's base layer. Layer 1 is sacred. It's the fundamental protocol, the ultimate source of truth, the bedrock of the whole system. It has to stay exactly as it is. All the clever tricks, all the adaptations, they have to happen on higher layers. So this is basically the blueprint for the whole thing. Let's walk through it. At the bottom, you've got Earth's Bitcoin. That's our anchor, our foundation. Then you need a way to send data through space, which is where a delay-tolerant network comes in. It's designed for that kind of spotty communication. Now, once you get to Mars, you have a local network, maybe a pegged sidechain to handle all the transactions happening on Mars itself. And for that daily cup of coffee, we're back to the Lightning Network, just with some settings tweaked for the delay. But the real magic, the thing that ties this all together, is this brand new accountability layer. That's the real breakthrough. Right, that accountability layer. This is the key innovation in the whole paper. It's a totally new concept they came up with, and honestly, it's the hero of our story. It's called POT. POT stands for Proof of Transit Timestamping, and the best way to think about it is like a cryptographically sealed cosmic FedEx receipt. It's brilliant. As a piece of data travels from Earth to Mars, every single stop along the way, every satellite, every relay station signs off on it. It adds its own tamper-proofed, time-stamped signature to this growing log. So check out how this chain of custody works. First, the Earth gateway sends the data and creates the very first signature. Then maybe a satellite in low Earth orbit catches it, checks that first signature, and adds its own. Then it gets handed off to a deep space relay, which does the exact same thing. By the time that data finally arrives on Mars, it's carrying this complete, unbroken chain of signatures. It's a perfect record proving exactly where it's been and when. So, what makes this cosmic receipt so incredibly trustworthy? Well, it boils down to 4 key things. First, you've got a hash of the data itself, which proves the message wasn't changed in transit. Then you have the signatures from each relay, proving who handled it. You've got timestamps showing when it was handled. And finally, all these receipts are chained together, which makes it totally impossible for anyone to reorder them or sneak in a fake one. It is a perfect, tamper-proof audit trail for deep space. Okay, so we have this amazing new tool, this POT system. This is great, but how do we use it to actually build a working economy between planets? More importantly, how do we get back to buying that cup of coffee on Mars? All right, this is where it all gets really practical. On the Lightning Network, payments are secured with something called a time lock. You can just think of it as a safety countdown, measured in Bitcoin blocks. Here on Earth, you might set that countdown to 144 blocks, which is about 1 day. So for a payment channel that stretches all the way to Mars, all you have to do is add a little extra time to that countdown to cover the 44-minute round-trip delay. The paper works it out. You just set it to around 157 blocks instead. That's it. It's such a simple and elegant fix. Now, you'd probably assume that keeping an entire planet's financial system synchronized with Earth would need just this massive fire hose of data constantly beaming through space, right? Well, the reality is, it's shockingly small. I mean, just look at this number, around 4.2 megabytes per year. That's it. That's all the data you need to send Bitcoin's block headers from Earth to Mars. This header-first method lets the entire Martian network know exactly what's happening on the main chain using an absolutely tiny, tiny amount of bandwidth. It's incredibly efficient. So when you put all of these pieces together, what does it really mean? What does this tell us about the future of money? And maybe even the future of humanity? I absolutely love this quote from the paper's conclusion because it just nails it. It says, "Physics forbids synchronous, cross-planet competitive mining, but it does not forbid a Bitcoin-only economy across planets." We can't change the laws of physics. Martian miners will never be able to compete in real time. But it turns out that doesn't matter. By being smart and building in layers, we can work with the laws of physics, not against them, and still create a single, unified economy that stretches across the solar system. And that really leaves us with one last big thought. You see, solving the puzzle of interplanetary money, it's not really just about finance. This is a blueprint. It's a model for solving all kinds of massive challenges with data and coordination across vast distances. So the question is, if we can build a system of trust for our money that actually works across the empty void of space, what else can we build? What about systems for knowledge, for culture, for governance that can also span the stars?